Welcome back. In this section, we are going to do a brief overview of some of the regulatory functions of the kidneys. And you'll go into more detail into the physiology later on. So one of the big functions has to do with water-salt balance to control how much water is being reabsorbed back into the bloodstream versus how much is being excreted in the urine. And this actually is directly related to maintaining the blood volume and thereby blood pressure. So this is a major role for the kidney. And another major role has to do with acid-base balance, where we need to keep that body in homeostasis. So let's look at acid-base. Oh, let's not look at acid-base first. We're doing the first one first. So let me point out something on this slide, which I will then go over a second time with you. The kidney releases renin into the bloodstream from that juxtaglomerular apparatus. And the liver releases a compound known as angiotensinogen. And renin acts on angiotensinogen to form a compound known as angiotensin 1, which is traveling in the blood. And don't forget then that the lungs secrete angiotensin converting enzyme. So now angiotensin 1 is acted upon and becomes angiotensin 2. And the role of angiotensin 2 is when it travels to the adrenal cortex, it stimulates aldosterone to be secreted by the adrenal cortex. And then the aldosterone has the effects that some of which you've learned about already, about sodium and water reabsorption. So let's put it all as a circle rather than linear at this point so that you can see this is all going to be related. The kidney releases renin, which acts on angiotensinogen from the liver to form angiotensin 1, which is then acted upon by angiotensin converting enzyme, which was made by the lungs. And so now angiotensin 2 was formed, which then acts on the adrenal cortex to have it produce aldosterone. Now, aldosterone has about half a dozen different effects. It's got some effects on the heart you'll learn about later. It has direct effects on the small blood vessels causing vasoconstriction, and it has the big effect on directly back on the kidney for sodium and water retention. And so the renin angiotensin aldosterone axis, or the RAA, or sometimes it's called RAS, RAAS, for renin angiotensin aldosterone system. The net effect of activating this is that blood volume is going to go up, blood pressure is going to go up. Okay. All right. So let's talk about something that's a little bit more fun. And that is things that increase your urine flow, things that are diuretics, because we consume a lot of diuretics, and I'm going to show you how they work just so you can see how they affect your daily life. And one of the things that folks consume all the time that makes you urinate is caffeinated beverages, whether it's coffee or whether it's a caffeinated soda or a Red Bull. The way the caffeinated beverages work is they increase the renal blood flow. So if you have more blood flow going to the kidney, then you're going to have more filtration. If you're going to have more filtration, then you're going to have more excretion of urine. In addition to increasing the blood flow, the caffeine also decreases the sodium that's being reabsorbed in the tubules, which means more sodium is staying in the tubule, so more water stays with the sodium in the tubule. So it's a double-pronged attack as to why you always have to go to the bathroom more often when you are drinking caffeinated beverages. So keep this in mind. If you're drinking caffeine right before you go to take an hour and a half or 2 hour test, that you need to make your last stop before entering the classroom. You need to make that last stop the bathroom. Now, if you're of age and you go someplace and you're drinking alcoholic beverages, or if you're drinking alcoholic beverages at home, the same thing happens, of course. And what you will learn is drinking alcoholic beverages makes you have to urinate more often. And this is because it inhibits your anti-diuretic hormone. So by inhibiting an inhibitor, this makes you urinate more. Lots of folks, especially if you are in the 60 and older crowd, maybe you ask your grandparents, your parents, they take water pills. Most of these are going to work by playing with the sodium reabsorption. But then, and so that's not relevant to you right now, but in case you had a parent or grandparent that took a water pill, now you know how it works. But then the last thing, once again, I'm going to talk about smoking. Because here's the thing, if you ever go to a bar or a restaurant and you're sitting someplace or you're at somebody's house and they are smoking and you're not smoking, please get up and urinate more often. In fact, you will find that you have to get up and urinate more often than the smoker does. And that's because the smoking cuts down on the renal blood flow. So even though the alcohol is inhibiting the anti-diuretic hormone, the decrease in renal blood flow is so significant that there's less filtrate. So they don't have to get up and urinate nearly as often. And having to get up and urinate after drinking alcohol, that's a good thing because it makes you realize sometimes how tipsy you really are. Maybe you should slow down your drinking. Okay, so for pretty much everybody, 1 alcoholic drink per hour, which means 1 shot per hour, meaning you now have 59 minutes and 58 seconds with no booze. So go for the mixed drinks or the taller drinks or the beer, things that you can kind of nurse over the hour. And be sure to eat plenty of food so it's not absorbed as quickly. All right, last regulatory function having to do with acid-base balance. So just to refresh your memory, pH scale goes from 0 to 14. If you are lower than 7, that means you have increased hydrogen ion concentration and you're an acid. If you're greater than 7, that means you have decreased hydrogen ion concentration, you have more hydroxyl groups. That means you are an alkali and that your blood likes to be slightly alkaline, 7.35 to 7.45. So just think right around 7.4. And it's pretty narrow range, even though this says a pH of 6.8 to 8 compatible with like 99% of the people with a pH of 7 are dead. Okay, so don't be counting on this. So how do we maintain the blood pH? Well, we already talked about this equation many times. So by now you're kind of sick and tired of it, but this is like the last time we are talking about it, this organ system. So we know that this end with the carbon dioxide, this is the part that we can alter with our breathing. If we increase our breathing rate, we are blowing off more carbon dioxide, or if we increase our depth of breathing, then we can blow off more carbon dioxide. And if we do the converse, then obviously carbon dioxide levels would go up. If carbon dioxide levels go up, that means the levels of carbonic acid are going to go up, which then means the levels of hydrogen ions and bicarbonate levels are going to go up. And it's this end of the equation with the ions that the kidney can play with. And the kidney has a choice of doing 2 things with each of these ions. It either, if it wants to get rid of it, it will excrete it. And if it wants it to buffer the pH, then it will send it back into the bloodstream. Like for instance, if you send positive charges back into the bloodstream, then the pH will fall. Whereas if you send negatively charged ions back into the bloodstream, then the pH will rise. So examples of controlling blood pH, give you example. If we want to raise our pH, we can blow off our carbon dioxide. How do we know this happens? Because if we blow this off, it means we have less of it, which means we have less of this, which means we have less of that. And then kidney-wise, we can either reabsorb the blood into the bicarb, which would raise the pH, or we can excrete the hydrogen ion into the urine to raise the pH. So that's that's pretty much it for regulatory functions in a nutshell or in a Sparks Note overview. And I will see you again soon because we have very little left to discuss. Thank you.